Hi everyone! In this video, we will perform and interpret a hypothesis test for a proportion using a calculator. A pharmaceutical company claims that fewer than 2% of their medication batches are defective. A regulatory agency wants to verify this claim before approving the medication for public use. An inspector from the agency randomly selects 400 batches of the medication and finds that 6 batches are defective. Use a graphing calculator to test the company's claim that fewer than 2% of the batches are defective at the 1% significance level. Because we're doing a hypothesis test, we need to identify the hypotheses. We can see that there is a claim that fewer than 2% of the medication batches are defective. This is a less than, fewer means less than, so the alternative hypothesis is that the proportion, so we use P, is less than 2%, which is 0.02. This makes the null hypothesis that the proportion equals 2%. We have some other items that were given to us. That the agency randomly selects 400 batches means that the sample size, n, equals 400. We also find that 6 of the batches are defective. This means x, or the number of successes, is 6. We were also told to test this at a 1% significance level, so alpha equals 0.01. We need to find the p-value and the test statistic using the calculator. Let's go ahead and draw this out so that we can visualize the test that we are looking at for this particular hypothesis. We see that we have an alternative hypothesis with a less than, which points to the left, and all of the numbers that are smaller are to the left as well, all as a reminder that it's a left-tailed test. And we are working with a significance level of 0.01. So our rejection region is down here, and the area under the curve is 0.01. To make a conclusion for our hypothesis test, we need to find the p-value so that we can compare it to alpha. To do this, we'll open up our calculator and go to Stat and go over to the tests, and we are looking at a 1 proportion z-test. We can arrow down or we can press 5 and enter to get down to our 1 proportion z-test. The proportion from our claim is 0.02. The inspector found 6 batches that were defective out of a total sample size of 400 batches. Our null hypothesis is a less than, so we need to highlight the lesser than, press enter, and then arrow down to calculate, and we will have our test statistic and p-value. Let's go ahead and write those down. Our p-value is 0.23, and let's go ahead and round 3 decimal places. The test statistic is negative 0.71, and let's again round out 3 decimal places. We were not given a critical value to compare our test statistic to, so we must compare the p-value to the alpha. Let's graph what the p-value would look like under the normal curve. 0.2 is a larger area than 0.01, so we need more area than alpha. Another way of doing this is to say that the p is larger than alpha. It does not fall in the rejection region, so we fail to reject the null hypothesis. To interpret this for the hypothesis test, we can say that there is not sufficient evidence to support the claim that the proportion of defective batches is less than 2%. And now we're all done.